Hey guys! All right, we are going to talk about ice ages. So, ice ages are the most researched dramatic climate change on Earth. So, that does not mean that it is the most dramatic climate change event, but what it's trying to say is that it's the most researched. So, we have a whole lot of information about what an ice age is and how it affected the Earth today. So, during an ice age is whenever the Earth's climate is a lot colder than what it is right now. It allows the glaciers to extend well beyond their ice caps. So the ice caps are just what's on top, what we see on top of the water right now for a glacier. But in an ice age, it's much bigger. In the past evidence, we had ice cores in the ocean floor. And this estimated that the Earth has gone through about 40 cycles of an ice age over the past 2.5 million years. So with the most recent one being 10,000 years ago. And remember, that evidence came from an ice core. And if you remember from the last video, an ice core is when they drill down into a glacier, pull out a core of the ice, and analyze the air bubbles that are inside of it. So variations in the Earth's tilt, again, the tilt and the orbit, around the sun happen in regular intervals. That's why we have seasons. Just everything happens in a regular interval. And each of these affects the climate. That's why we have seasonal climates also. So moving forward, every 40,000 to 100,000 years, the Earth's tilt and orbit makes such an impact that we have cooler summers in the northern hemisphere. Moving on. Okay, so the most recent climate change that's going on right now. So over the past century, that's 100 years, over the past century, scientists have found that global surface temperature over the past 140 years is increasing, and that's an alarming rate. This is called global warming, and I'm certain that you've heard about it. So what is global warming? It's whenever the globe's heating up too much. So the Earth is getting too hot, too fast, much more than the normal rate. So if we look here on this, on our graph right here, you can see that in the 1800s, it was right about here. In the 1900s, see, it was staying low. Then we got a little colder. Now we're starting to get hot here in 1940. And then we go down a little bit. Anyway, as you can really see, about the mid-1960s, we just started skyrocketing. So we have a whole lot more things going on right now in the world, which are contributing to this incline of the global warming, of the climate change. So scientists are gathering the data in the amount of greenhouse gases. Now, if you remember, greenhouse gases are like methane and carbon dioxide and nitrogen, everything that goes up into the world and is trapping in that heat. Now, since we've had an increase of these greenhouse gases, that means that there's an increase of heat because it's trapping more. So all of this data suggests that our Earth is heating up at an alarming rate, and we've got to figure something out. All right. And we're going to learn about that. All right, so human activities, things that humans do every day are what is contributing to this increase in climate change. So things that we've seen so far are like mining. There's other industries. There's deforestation. There's agriculture products, things of that nature. Now it's releasing greenhouse gases like methane and carbon dioxide in excess amounts. By excess, we mean too many, too much. And that's increasing the concentration of the greenhouse gases. Now, concentration means how many in one specific area. So because we have more greenhouse gases going out, that means we have more in a small amount of area, which is our atmosphere, which causes the globe temperature to rise. Most of these greenhouse gases are coming from fossil fuels, which are formed from the remains of prior organisms. So if you've ever heard of a fossil fuel being like a dead dinosaur, kind of. It's just the remains of organisms that have been buried down deep, and then we burn them and it becomes fuel. That releases a whole lot of energy every time they get burned. So these activities are measured by humans, and we call them a carbon footprint. Now, one of our activities that we will get to do is creating our own not creating it, but calculating our own carbon footprint. So if you want to figure it, play around with it before class, that's totally fine. But we're going to be doing it on that. It's right there. The website that is embedded in here. And we're also going to be looking on page 464 and 465 in class. So just hang tight and we'll get to those activities and learn a little bit more about the carbon cycle. So the carbon cycle is like the water cycle, but with carbon dioxide. So if we look here, we've got carbon dioxide going up into the air, and then it comes down by way of rain. So it can go up into the air, and then it comes to get, all the gases get trapped, they get into the water, and then whenever it rains, it all comes back down. We've also got animal perspiration, and that's whenever, animals, I say perspiration, respiration, that's whenever the animals breathe out. We do it too. Every breath that comes out is respiration. It's an inorganic carbon release into the atmosphere, which is why we need trees. We also have plant respiration. We got root respiration. Everything gives something off. Pollution is one of the big bad ones. That's another inorganic carbon that is released into the atmosphere. So this whole picture right here has a lot to do with it. It's very similar to what the water cycle does. It goes up and it comes back down and then it cycles again. And then we've got some common misconceptions over here. So you can check that out, that every plume of smoke is contributing to the CO2 increase. That is not true. If you drive past a factory and you see plumes of smoke coming out, that does not necessarily mean that they are polluting. That does not necessarily mean that. It just depends on what they're putting into the atmosphere. Now, a lot of times it is. If you see it coming out of a car and it's black, that's contributing to the carbon problem, the greenhouse gases. Some things in the carbon cycle are totally natural. These things happen all the time, like you and I. We're breathing out carbon dioxide. That is a natural process. That's okay. It's just the things that we do as humans that we do in excess and make things a little bit harder on our Earth. And then it's getting too hot. So we do need some CO2 in the air. As you know from earlier, you've got to have something trapping in the heat. But again, with the carbon, with greenhouse gases and the global warming, it's happening too much. So let me move my little face here. Okay. So we've got the concentration of the Earth's atmosphere. If you look here on this graph, you'll be able to see how many CO2 parts per million there have been over the past several years. By several, I mean hundreds of thousands. So 400,000 years ago, it's estimated that there was only 280 CO2 parts per million. Okay. And that may be a really tough thing to try to grasp and understand, which is totally fine. But just look at the way that the graph is set up. It goes down and up and down and up. And then look at close to today. Just spikes all the way up, higher than it's ever been, up to 400 million. Oh, too far. All right. Well, that'll be that. So I will see y'all tomorrow. Bye. Maybe.